Hi, this is Raphael with Looker. In this demo, we're going to quickly go through every step of Looker from creating a database connection to generating an initial data model, to exploring that model, iterating on the model, and building dashboards and reports from it. And in 3 simple steps, the way the Looker works is you connect to your database in the admin panel, you describe to Looker what's inside of your database, the data structure and business logic and whatnot in this LookML model. And then you can explore that data by adding in fields and pivoting around and drilling in and filtering on things. So first things first is we go to the admin panel to create our first database connection. We'll go to database connections, add our first database connection here, and select our dialect. This is the dialect of SQL that Looker will compile down into from your LookML model. So if you're using Amazon Redshift, you'd select that dialect. MySQL, you'd select that one, or any of the other relational SQL databases that Looker integrates with. You would add in your name and credentials here, and then add the connection. Next thing is we're going to implement our data model before we start exploring it. Well, we go to Manage Projects, and you'll see a list of existing data models and data projects on this demo site, but we'll create one from scratch. In the bottom right is where you can create a new LookML project. Let's create the first LookML model by going to New LookML Project in the bottom right. We'll give this data model a name, such as e-commerce. Select the database connection, which is the Look2, and create this by clicking the purple button at the bottom. What this will do is it'll generate our initial data model. So what we're looking at right now is the LookML file called e-commerce that is a model file describing the tables it found and the relationships it found in our database. You see how it says explore events, explore inventory items, explore order items. If I click explore, I can see in the list I already have this e-commerce model where I can start exploring all these tables directly right after generating that model. And if I were to start exploring order items data, I would be able to slice and dice by inventory items, orders, products, and users data because these joins are all defined here. Looker looks for obvious relationships between tables on standard primary and foreign key relationships, such as order items inventory ID it found, so it thought it was obvious to join the inventory items ID column onto that table. If this relationship is wrong or you want it to be something else, you can delete that from the model or define it in a different way. Or you can define a relationship that it might not have found, such as a weird table that joins on the strange ID. If it's not a straightforward column-to-column relationship, you can write in your own SQL here by going beyond LookML and writing in whatever you'd like it to write for you in SQL. Essentially, what you can think about is you're training Looker how you want it to consistently write SQL for everybody in your whole team, so that you only have to define that relationship or that business logic once, and then it's replicated over and over in a consistently accurate fashion. So we'll get rid of this for now and start exploring our data. If I click Explore on the left, we'll start exploring order items. I'm going to open this up in a new tab. And I've now opened the exploration interface for order items. So what you can think of is this is really just a humongous spreadsheet about order items or a gigantic playground or universe for us to explore things about this entity. We have order items data, we have orders data, products data, users data, and inventory information that relate to these order items. And these types of fields that we can select for our queries are dimensions and measures, where dimensions are attributes about these entities, such as the cost of an inventory item, the sale price of an item that was ordered, the status of an order, the category of a product, or the age of a user. And measures are aggregate operators over multiple records, such as the counts, sums, averages, conversion rates, growth rates over multiple items that were ordered. So for aggregate analysis, you're typically adding in a measure and slicing it by a dimension. So we'll start off with some basic queries and then gaining complexity quickly. Let's say we just want to count up the number of items that have ever been ordered on this e-commerce site. I'll click on order items, go down to the count measure. If I left click on this will add it to our table to query. I'll click the run button. And right away, we can see there's 50,991 records returned. So presumably, that's how many items have been ordered on this website. The way the Looker got this number is it wrote SQL for us. You can click on the SQL tab to see what Looker actually just did. It wrote select count star from order items. No joins, no where clauses. Looker's going to write SQL in the most performant way that it can based upon the question that you're asking it. So that's nice. We have the count of items that were ordered. Now let's say we want to group this by something, such as the date that they were ordered on. I'll click on orders, create a date, click on the date dimension, and let's just filter for the last 30 days. Click run. And now what we're looking at, if I click and sort the create a date column here, the count of items that were ordered by day for the last 30 days per our filter. You can drop down the filters and open up the visualization tab. look at this as a column chart, a line chart, an area chart, and see this in a time series. The way that Looker produced this result set is it wrote different SQL. If I look at the SQL here, it's doing a data extraction from the orders created at timestamp and left joining in orders on these primary and foreign keys, as well as adding an aware clause for the interval of 30 days per our filter that we added above. So filters become where clauses. It'll do joins if it needs to, such as joining orders to get this orders created at timestamp, and it understands how to execute this join based off of the relationship logic that you've defined right here. This is Looker's instructions manual or reference area that tells it how to accurately execute SQL for you as you query and iterate on questions. So we can do that. If we want to add in another measure, let's say the count of users that are ordering these items, I'll go to users count, and you'll see it'll do a count distinct of the user IDs and join in users on these primary and foreign keys. And again, it's referencing your model right here. These 2 lines of code tell it how to execute that join correctly. So I can run that. And now we're looking at both these measures plotted. That's essentially what Looker's doing. You're adding in fields, filtering, and it understands how to compile SQL for you depending on what query you're asking from it. Some other things you can do here is pivot and drill. So let's say we wanted to not only know the number of items ordered and the number of users ordering these items by date, we also wanted to split that out by the gender of these users. Under users, there is a dimension called gender, which I can click on to add it to my table, or I can pivot on this. If I click pivot, it'll become on the upper axis, and I'll click run to now find this same data split out by the gender. So let's drop down the table of data and look at this on a visualization, maybe a line chart. Maybe you want to change the way that this line chart looks. Some visualization options here. And then let's say we want to drill into more information. So we just pivoted on gender, and perhaps we see a spike somewhere, such as this spike of items that was ordered. There was a large spike on June 17th, and we want to know more about perhaps these users that ordered it. Maybe I'm just interested in the female users. We're looking at the spike of items that were ordered by females and these 23 users that are females that ordered that large group of items on that date. If I click on 23 right here, it will drill me into the detailed information about those users. I'm now seeing the users' IDs, their last names, their first names, how many orders they placed. You also in the model can define the drill path. So if you want a different set of fields to appear when you click and drill, that's completely within your control to define what that drill path will be. We're also still in the Explore area. So if we want to know more information about these user IDs, I can click on any of these dimensions under users, such as their age, their city, their country, when they created an account here, their email, their gender, the traffic source they came from, their zip code. I can add those fields, click run, Looker will fetch that information live from the database, and now we have that in our result set. And once you have a result set like this, you can save this in the upper right. You can download this as a CSV, JSON text, or Markdown file. You can share this with somebody else by clicking the share button and just copying and pasting this URL into their chat or email. They can open that up in their own web browser and see the same result set. Now what I'd like to do is go into the view files a bit. In the bottom left here, this is where you're actually defining in LookML the field level definitions for your dimensions and measures, how things are calculated, any derived dimensions or columns you want to create. So let's start by going to order items. I'll click on order items. This is going to bring up the LookML view file for order items, this table in the database that has the field definitions for all the dimensions and the measures. So the generator, when we just generated this 10 minutes ago, created these dimension definitions for the columns in the table. So the way to read this dimension is the dimension title is ID. It is the primary key of this view. The type is an integer, in other words, how it'll appear on the table. And the SQL definition for this dimension is the order items ID column itself. Another one would be this dimension sale price. The dimension name is sale price. The type is a number. The SQL definition is the order item sale price column itself. If we want to create a derived dimension, we can as well. Let's just copy and paste this code. Let's say we want to know the profit of any individual item that was ordered. We'll title it profit. The type is still a number. The SQL definition is going to be the sale price, which is defined above, minus the inventory items cost field. So what we're doing here is we're referencing sale price, which is defined above. It's going to execute the SQL and then subtract the definition of cost, which is found in another view file. I'm already familiar with this data set, so I know that there's a cost field there. But what you can think of is it's just going to reference a previously defined dimension or measure. In other words, this could be a lot more complex, such as a pipe case when crazy function What Looker would then do if it was that is it would reference the sale price dimension, execute this case when crazy function, etc., and then subtract some other potentially complex SQL transformation in another view file elsewhere in your model. What it comes down to, though, is that everything flows down to a root source, which is the name of a table itself in your database or the name of a column in the table. This is nice from a developer's perspective in that if any column or table name changes on your database and things start breaking, your reports start breaking in Looker, all you need to do is just add the new column name here, and that will flow through the rest of all of your derivations and metrics, and your whole application of Looker will be domino effect fixed right away because it all pulls back from a root source and everything is nested with inside of each other. So that's how you create a new dimension. To create a new measure, it's the same. You could just copy and paste this measure. Again, measures are aggregate operators, such as counts, averages, sums, and furthermore. We'll call this measure total revenue. The way that we'll calculate this is a sum instead of a count. And what we want it to sum over is the sale price dimension. So what we're telling it to do is scope to sale price, execute this for every record, sum over it, and alias this as total revenue. Same thing will be for profit. Still going to be a sum, but we want to sum over profit this time. We'll scope to the definition of profit, execute this for every record, and sum over it and alias it as total profit. Last thing is I wanted to go over was drill fields. Remember when I clicked on users and it drilled us into all those user IDs, last names, first names, and the count of orders they placed? This is actually where you define those columns and which will appear when you click and drill into a particular model in the data application. So let's say, for instance, if somebody clicks into a spike or dip in total profit, it would be useful for our business users to see the individual transactions associated with that total profit, such as the ID or the product's item name or the user's email that ordered it or the sale price or the profit of the item. This is where you define the fields, and that's what will appear when they click and drill into that. I'll copy and paste this, have the same drill fields for total revenue. Another way to create drill fields is defining the drill path into a different level of aggregation, such as if somebody clicks into a count of items, perhaps they don't want to actually drill into every single item ID. Maybe they just want to isolate that account and slice it by more fields on the left. So we can just drill into the count itself. And I'll show you how this works when we start exploring the data. So save my changes in the upper right. And now we'll start exploring some of these new fields that we added. Again, we added a profit dimension, total revenue, and total profit measure, as well as the drill fields for these measures. So I'll click on order items, explore order items, open up the order items explorer view in a new tab. And under order items, we now have our new dimension profit and measures total profit and total revenue. So let's say we just want to see the way that Looker's calculating these measures now. Count, total profit, total revenue. I'll add those to my table, click run, and you'll probably have an idea of whether or not these are remotely accurate. But you can look at the SQL to see how it's calculating this. Sum over sale price, or sum over sale price minus inventory items cost, alias is total profit. That's good. It's calculated in the correct way as you trained it to do so. But now we can start slicing this by a bunch of stuff. If we want to slice this by the category, we can find the category and click run and slice this by category. If we instead want to slice this by the gender, we can find the gender field, add that in, and slice this by the gender of users. Or let's say we want to slice this by the month that these items were ordered. I can find the orders created month, add that in, and click run. Create a visualization or time series off of this, and start exploring and drilling into this data. We see a dip right here. It looks like February 2014 was pretty bad for all of our metrics, total profit, total revenue, and total volume of items ordered. And if we want to click into more detail, we can. Let's say we just want to isolate the total count of items and drill into these 1,400 items that were associated with that dip in February 2014. If I click onto the 1421 here, it will drill me into the count itself. In other words, it really just isolates that 1421 number. The filters are passed through for that month. And the reason why it just isolated this 1421 number is for that measure, order items count, we defined a drill path that was just the count itself. This is valuable because we found that spike on our chart, we've isolated that 1421 group, and now we can start slicing it to explore that group in more detail. Perhaps we're curious and we think that it might have something to do with the category of items. I'll click on products category, run this, and start searching by the category. Maybe we want to remove that and look at the location that these items are coming from, such as the state. Maybe we want to create a visualization off of this and then drill into one of these states. Perhaps California, we want to know about these 272 items in California. Click on California, and it will isolate that 272 count in California. Of these 272 items that were ordered in California in that month, let's slice that by the category, and then maybe add back in our total profit measure and see what was the most or least popular category by volume or most or least profitable category. If we want to drill into any of the items that were associated with categories of low profit, we can by clicking into the total profit measure. For instance, it looks like only 11 items were ordered in the socks and hosiery category, which brought us in just $60 in total profit. If I click on that $60 in total profit, it will drill us into the drill fields that we define, such as the order item ID, products item name, user's email that ordered it, sale price, and profit. And again, these fields are the fields that we defined in the drill path for that total profit measure. These you can adjust to what your business users will find the most value from as they click and drill into your respective measures. But again, they're still in the Explore area, so they can just add in other information here if it helps them. So this is essentially what you're doing in Looker. Again, you're defining the data structure and relationship logic in the model file, and then defining the derivations and then defining the field level definitions, which are derived dimensions or measures about your entities. The beauty of this is that once you've defined the business logic in the view files and the relationships in the model file, these are all modular components that Looker understands at a deep level and can compile into consistently accurate SQL as you iterate on your queries in real time. So this is all the SQL that you never really would need to write yourself. As simple query questions change over and over from your business teams, they have an interface they can go into, add in their own fields, run their own queries, and get their own data. Or if you're still going to be delivering the data to them and running queries for them, you can just click on fields rather than needing to worry about editing your raw manual SQL or wondering if it was accurate based on other SQL queries you've written in the past. Looker knows how to do it for you. Last thing I want to show you on this demo was building a dashboard. So what we'll do is we'll wipe this query of all the filters and fields and just create a couple of saved reports or looks that we'll add to a dashboard. Let's create a simple one such as the volume of items ordered and the profit of items over the last 30 days, a time series chart. We'll go to order items count, total profit, and we'll group that by the date. Filter for the last 30 days. Now we're looking at this as a table. Let's say we want to add a visualization to our dashboard, such as a line chart. Maybe change the aesthetics of this a bit. Click on the gear in the upper right and add this to a dashboard. It'll first prompt us to create a new look, which is like a saved query. We'll title this order items count and profit by day. I'll create this as a look and then add this to a new dashboard, which I'll call demo dashboard. I'm going to create and view this dashboard. And you'll see that it just took our visualization and inserted it onto this dashboard for us. I can change the height of this element if I want. I can also add in global filters onto this dashboard if I'd like. So for instance, perhaps a team wants to check out this on a regular basis, but they want to be able to filter on the date range. You can click on the gear in the upper right, create a global filter, such as the date. The filter type will be a date. Let's default it to the last 30 days. And then have our order items count and profit by day element listen to this and apply it to a particular timestamp of our choice. In this case, the orders created date, although there may be other elements that you'll want it to apply that date filter to the user's created date. We'll just do orders created date for this one. And now our business users that are accessing this dashboard can change the filter if they'd like, such as looking at just the last 15 days or the last 60 days. Let's add one more element to this dashboard and call it a day. I'll go back to Explore Order Items in a new tab. Let's create a table that shows the top 15 items for this year. I'll go to Products Item Name, Order Items Count, see how many of these items are ordered. Filter just for this year. And do a row limit of 15. Now we're looking at by volume, the most popular items. I'll add this to my dashboard by going to the gear, add this to the dashboard, Save it as a look. And add this to an existing dashboard that we call demo dashboard. And voila, it's added to our dashboard at the bottom, along with our time series analysis of items and profit over the last 30 days. You can also move these elements around in whichever way you'd like, and again, adjust the height of each row. So essentially what you're doing, again, is developing a data application that describes the data structure and business logic where you can endlessly explore data, build up aggregate analysis, drill down into detail, and share and iterate on your data. Thanks for listening. This has been a very quick intro for the basics of Looker, which involve connecting to a database, generating a data model, exploring the data model, developing the data model, and leveraging the data application of Looker to access data, query data, build dashboards up from. There's some additional features of Looker that we didn't get to cover in this demo, such as scheduled emailed reports, alert notifications, and feeding data into other applications such as spreadsheets, R, or elsewhere. If you have any questions, please contact support@looker.com or visit our website for a demo or free trial.